All right, and share my whiteboard. Okay, so this is the whiteboard. So let me just get the question paper out because I have the solutions I'm going to work through now, right? So and the first question is basically your last learning unit. So remember in your exam, you're not going to be told what learning unit that question is. You need to understand which learning unit that question falls under. All right, so it's something that it's a skill that you're gonna have to get familiar with when you're writing this exam. So the first question, it basically says you wish to determine whether there's a relationship between gender of a teenager and their preferred brand of shoes. So what they're looking at, let me just start writing. And if you can't see the whiteboard, please do let me know. All right, so what they're asking is they're testing for a relationship between gender and shoe brand. All right, and they give you a table, basically a cross-tabulation table, which has females, so they has gender here, female and male, right? And then there's 3 brands of sneakers, which is Nike, Asics, sorry, my spelling is bad, Asics, and the last one, which is New Balance. So I'm just going to write NB for New Balance. And then in each of these intersections, so for females that prefer Nike, there's about 28 of them. For Asics, there's 32, 38 for New Balance, 19 for Nike and males, 24 males use Asics or prefer Asics, and then 59 males prefer New Balance. All right, so this is what will be given to you. What you should do is you need to add in the totals yourselves. Okay, so you'll add up the totals for the columns. So for Nike, how many people in total use Nike? So you're adding up 28 and the 19, yeah, and that's 47. So sometimes they won't give you the totals, or sometimes they will. Hopefully they will, so it saves you time, but otherwise you're going to have to include those totals. So there's 56 people in total that use Asics and 97 use New Balance. The grand total of everyone is 200. Then I'm going to add the totals going across the columns. So how many females are there in total? And that's 98. And then the total for males is 102. All right. So that's the information that's given to you, and they want you to test this here. Is this true? Is there a relationship between gender and shoe brand? All right. So what I'm going to do is I'm going to start writing here in the bottom is the first step to actually is to identify what learning unit this is. And this is learning unit 9. This is the last learning unit. This is the chi-square distribution. So whenever you're testing whether there's a relationship between 2 variables, and in this case it is because you're testing the relationship between gender and shoe brand, then immediately you need to identify that that is the chi-square distribution. All right, you're going to have to use that test. So what you would do for all hypothesis tests is you need to state what H0 is and what H1 is. Okay, now for the chi-square test, you need to remember that H0 will always be the case where the variables are independent, or in other words, there's no relationship. So you could say, one way of stating this is you could say gender and preferred shoe brand, I'm just going to put shoe, right, are independent. All right, and then for H1, you could simply just say the same thing. It's basically, it's not H0, right? So it's H0 is false, so it'll be gender and preferred shoe are, instead of saying independent, you can say dependent. It's the opposite of that. Okay, any questions so far before I proceed? So this is your first step for your chi-square test. This is your step 1, is stating H0 and H1. Remember, H0 is always the case where there's no relationship, or in other words, they're independent, and H1 is when they are dependent. All right.
Yes,
So
all good, sir.
look, oh good. Okay, fantastic. Great, great, great. All right. So remember, just if you need to ask anything, please just unmute and ask away, or drop a text in the chat. Okay. And rather ask now instead of me going further in, and then you're going to be more lost. All right. So I'd rather, where you're having difficulty understanding something, I'd rather just attend to it right there and then. All right. So you guys gotta let me know.
Thanks, sir.
All right. So that's step 1. All right. So I'm gonna clear out some space here. I'm gonna I'm gonna clear out the entire thing, right? All right. So we stated our H0 and H1. The next step is to find the acceptance and the rejection region. All right. So what you need to do for that is first you need to determine your degrees of freedom for the chi-square test. Now we are doing a test of association, all right, or an independence test. And the way to find your degrees of freedom is your rows minus 1 and the number of columns minus 1, then you multiply that together. Now remember, for rows, we had male and female, so there's only 2 rows, right? So R is 2. So it's 2 minus 1, and the columns is basically the shoe brands, right? So you had 3 shoe brands. You had Nike, Asics, and New Balance, so it's 3. So that's 2 minus 1 into 3 minus 1, and if you multiply that out, you will get 2. Remember, BODMAS, you do the brackets first and then you do the multiplication in the end. All right, so that's 2. That's our degrees of freedom. Now, why do we need our degrees of freedom? Because remember, the chi-square test requires your degrees of freedom to find that rejection region, because even though you know your alpha, right? And in our case, your degree or your level of significance, which is your alpha, is 5%. So your alpha is 0.05, which is given to you, right? 0.05. You still need the degrees of freedom to determine what the critical value is. So you would need to go to your chi-square table, right? And in your chi-square table, you'll have your alphas going this way, and you'll have your degrees of freedom going this way. So you need to know where to stop going down the rows in order to find your critical value, and that's why you had to find 2. Now if you go to your table and you look at where 0.05 intersects with 2 on your chi-square table, you will see that the value that you get there is 5.991. 5.991. So that means this is the critical value. Anything on the right of this, okay, you reject H0. All right, and anything on the left of this way, we're going to accept H. All right, and anything on the left of this way, we're going to accept H0. All right, there we go. That's how you find your rejection and your acceptance region. All right, so that's pretty much your step 2 done. Now your step 3 is what's going to take the bulk of the marks, right? It's going to take up most of your time in this question because there's a lot of working involved, but also this part of the question is where you get the most marks, right? So it's very important that you understand how to do this step. So what you need to do first.
Sorry,
Yes?
sorry. This chi-square table, do you find it in the question paper?
It's in your formula sheet in
With
the
the
back of the
degrees?
exam. Yeah, so it's along
Oh, okay.
with all your tables and formulas here.
Oh, thank you, sir.
Yeah, that'll be given to you, yeah. Okay. All right, so let's clear this board. I'm going to move on to the next step. Now, in the next step, it's basically finding out your test statistic. And to do this, you need to create a table. Now, sometimes in the exam, they'll give you the start of the table. What I'm saying start off is they'll give you the template, so they will lay it out for you, having, in our case, let me get the pen again. All right, so in our case, they'll have female, right? And then for each female, there's 3 brands, right? There's Nike, Asics. I'm just gonna write N for Nike, A for Asics, and NB for New Balance, okay? And then you can have the same thing for males because they can also take the same 3. So here you'll have Nike, Asics, and New Balance. And this is the template I'm talking about. Sometimes in the paper, they'll tell you to structure the table in this format. If not, then you'd have to use your own discretion to structure it. Basically, you can have your row variables first. So I have here male and female. And then you got the column variables next to each of them. All right. And the first column, you would have your F0. And your F0 is what is your observed frequencies. Now, those are given to you. Okay, it's in the question. So basically, I'll populate it now, and this is nothing new. It's just what's given in the questions. So for females, there are 28 of them that use Nike. 28 is 32 for Asics. For New Balance, 38. 19, 24, and 59. All right, the total of that is 200. Okay, so that's your F0 column. The next column is your FE, and this is your expected frequency. Now, this is where you're required to do some calculations on your side. Okay, now to work out your FE, all right, the formula when you're doing this specific chi-square test, okay, I don't know what happened there. When you're doing this specific chi-square test, which is the test of association, you need to use the formula row total. Okay, hold on. Okay, you're going to use the formula row total. I'm just going to write tot for total times column total, all divided by the grand total. That's the formula you need to use. And this formula isn't given to you, so you need to remember this, okay? Row total times column total over the grand total. All right, so let me just show you how this works, and it kind of will give you an idea of how to use this. All right. So let me erase this to get some space. Row total times column total over grand total. I do apologize if you hear any noise in the background. I think my kid is up and about. All right. Okay. Let's see. Row total times column total over grand total. So let's look at females, right? So that's remember now we're looking at the first point here, which is females, and that's the row. Okay, so the row is females. If you add up all the females, you get 98. So that's the row total, 98. And then the column total here is Nike, right? We're looking at the first brand is Nike. So how many Nike users do we have in total? And that is 47. And then the grand total is here. It's this here. It's 200. Divide that by 200. Now, if you work that out, you'll get a value of 23.03. 23.03. All right, so let's do the next one, and you kind of have an idea of how this actually works. So the next one, we're still on females, right? So it's still going to be the same row total, which is 98. But now we're dealing with Asics. So how many people in total use Asics? Well, that is 56. And then once again, we divide it by 200. And if you do that, you'll get a value of 27.44. 27.44. So I'm going to populate the rest of the values, but I think you get the idea of how to do each of them. All right. Just let me know if anything's not clear. On how to do this working. So it's 47.53. Next one is 23.97. And then the last two is 28.56. And then the last one is 49.47. All right, so that's your FE. Now, this is the column you'd have to do the calculations, okay? So make sure you understand how to do that. The last column that you need to work out, right? And you could break it up into 2 columns, but I'm going to do it in one step here. All right, so this is your F0 minus FE all squared divided by FE. All right, so the reason why you need this column is because the chi-squared, the test stat, the formula, this formula is given to you. It's sum f of 0 minus FE all squared divided by FE. Okay, you're summing up this entire thing. Now, if you look at what I have in the brackets, it's what I have here. So what I need to do is I need to work this out for each of them, and in the end, I need to add it up. I need to add up the entire column, and that will give me this value here. Okay, so that's why we're working out this column here that you see there. All right, so if I'm just going to make some space here. All right, go. Okay, so instead of putting in the denominator, I'm just going to write it like this. So I got space to write. So the first one is if you plug in this F0 value, this FE value, all into this equation. If you work it out, you punch it into your calculator, you'll get a value of 1.07. 1.07. Okay, the next value, you do the same thing for each row, it's 0.76. All right, 1.91. 1.03. Right, 1.91, 1.03. Okay, the last 2 values is 0.73, and then the last value is 1.84. So it's just punching all the values into your calculator. That's essentially what you're doing. And if you sum them all up, so if you sum up this entire column of values, you get a value of 7.34. 7.34. Now that's your test stat. And now this is important because this is what you're going to compare to what your critical value is. So that's what I had before I raised the whiteboard. The critical value, remember this chi-squared diagram I had, went up like that, there, and I said anything greater, so anything on this side of 5.991, we would reject H0. Now looking at this value that you got here, where does it fall on this graph? Does it fall on the left of it, or does it fall on the right of it? If you look at this is the value of 5.9. Very good, Victor. So we reject H0 because it falls in the rejection region. It's on the right of this 5.991. So we reject H0. All right, and then your final step is you need to write it out in words. Okay, so now I'm just gonna remember, keep this in mind, we're rejecting H0, okay? So just to recap, in my first step when I started off this problem, I said H0 is, okay, H0 was that gender and preferred shoe brand were independent, right? And then H1 was H0 is false, right? So basically the opposite of H0. Now remember what we just concluded. We said we're going to reject H0. That's what we just found out. So that means we are rejecting this. So that means we would accept H1. So what we're saying is that gender and preferred shoe brand are actually dependent based on a 5% level of significance. Because remember, that's what your alpha was. You must always mention your level of significance. All right? That's essentially how you would answer that problem. Okay, so you're saying gender and preferred shoe brand are dependent. Okay, something the opposite of this because we're accepting H1 instead. All right, so does that make sense, everyone? That's pretty much how you answer that question 6.1, a 10-mark question. All right, if there's no questions, I'll move on to the next one.
Would you, sorry, sir, did you say that gender and shoe are dependent based on what, sir?
On a 5% level of significance.
Okay, thank you.
All right. Yeah, you must always include your level of significance in your conclusion, in your statement. Remember that.
Thanks, yeah.
Okay. No worries. All right, let's move on to 6.2. All right. Now 6.2, it's a financial manager of a national warehouse chain has found that previous experience has shown that 60% of clients pay by credit card, 30% pay on account, while the remaining clients pay using cash. And he wants to know if this is still the case. All right. So now, what happens with these kind of questions? Okay, what you need to take away from it is they're looking at one point in time versus another point in time. So at one time, so let's just say, let me just write this here. Okay, so here. So doesn't matter what the time was, and let's just say this was time 0, and this could have been 3 years ago, right? Now we're maybe 2 years later. Now, say there was a certain distribution, and when I say distribution, it's like basically proportion of different types of categories. So in this case, remember, at this point in time, what was happening was that you had clients paying by credit card, and that was around 60% of them. And then there were also clients paying by accounts, all right, taking like a store account, etc. And there were 30% of them, right? And then lastly, the remaining clients would pay by cash, right? So that was the remaining, which is just basically 10%, because remember, everything must add up to 100%. Now what they're saying is, okay, what we've done is, it's 2 years later, we want to know if this proportion still holds, this distribution still holds. Maybe it's changed, maybe less clients are paying by credit card, and that's what you're basically testing. So 2 years later, or whatever the time is for this problem, they've now found that when they looked at this table, they now found that, not table, sorry, when they actually did a survey or do a sample, they found, okay, we've got credit card clients, but we only find 620 of them. So we got the numbers, and then we have accounts, the other type. They found that 260 of them pay by accounts, and then lastly, the remaining clients pay by cash. This is what is given to you. So no working out at the moment. It's just giving you these observations. All right. So this is your F naught. Right. This is the observed frequency. Now, the first step that you want to do for all chi-square tests, because this is a chi-square test, but it's a goodness of fit test because you're testing whether there's a change in distribution. So the first thing you'd want to do is state your hypothesis, right? So I'm just gonna maybe write it out here. Okay, here's your H naught, and you're gonna have your H1. Right. Now your H naught is that it's always going to be that the distribution has not changed, okay, or it's the same. So in this case, in terms of the problem, what you're saying is the payment methods, I'm just going to write PMT for payment. So the payment method, right, has not, so we could say payment method pattern instead of saying distribution. You could say distribution if you want, that actually works better, but let's say pattern. The payment method pattern has not changed or still the same. Okay, your H naught will always be the same or not change, same thing. Okay, your H naught will always be the same or not change, same thing. Your H1 is the opposite of that. So you could just say payment method pattern has changed. That's your H0 and H1, right? That's how you would state it. Okay, now, as before, you need to find your acceptance and your rejection region. Okay, now for your degrees of freedom, now for the goodness of fit test, before we used R minus 1 into C minus 1. That's before. But now for the goodness of fit test, you don't use this. All right. So you're going to use a different formula, and I'm going to just clear this out. And the reason why we don't use this is because there are no columns. It's just the rows here. You're only given 3 categories. So for this formula, you use your degrees of freedom equals to K minus M minus 1. Now you may wonder, okay, what is K? Well, K is just basically how many categories you have. And you can see we've got 3 categories. We've got credit card, that's 1. The second category is accounts, and the third category is cash. So your K is 3. 3 categories. And if you remember from the lecture, the collab that I did, your M is, unless it is a they're telling you to test whether it's a normal distribution or a binomial distribution or a Poisson distribution. If they mention those distributions, then your M is going to have a value. But other than that, your M is going to be 0. All right. So in this case, they're not telling you to test whether it's a normal distribution. They don't mention anything about a binomial. Neither do they mention anything about a Poisson distribution. So here your M is going to be 0, right? And then your minus 1. If they're telling you to test whether it's a normal distribution, your M is going to be 2. If they're testing whether it's a Poisson distribution, then your M is going to be 1. All right, keep that in mind. All right, but other than that, it's very unlikely that they would test you on that. Most of the time, they don't specify distribution. All right.
And if it's a binomial,
and if it's a binomial, then I believe it is 2. It's also 2. It's basically
just like a normal distribution.
Yeah. So yes, because what the M represents, it's a number of parameters for that distribution. So for instance, remember a normal distribution, to work out any probability for the normal distribution, you need 2 parameters. You need its mean and you need to know the sigma. If you don't have those values, you can't work out any probabilities. The same thing for a binomial. A binomial, there are 2 parameters. You need to know the number of trials, which is n, and you need to know the probability of a success, right? Those are the 2 things. If you don't have those 2 values, you cannot work out the probability. So that's why it's 2 here. It's 2 here. But for the Poisson, you only need to know the average. Sometimes that average is denoted as A or lambda, but you only need to know 1 value, and then you can work out the probability. So that's what that M is. It's basically how many parameters these distributions need. All right. Okay, so let me just clear that out. Make some space here. All right, so it's 3 minus 1, which is 2. That's your degrees of freedom. And our alpha, which is a level of significance, also is 5%. So that's 0.05. So now you can work out the critical value, right? So remember your critical value is, there's your graph, there's your chi-squared, somewhere on the top here. So if you use your degrees of freedom and your 0.05, you go to your table and you find that critical value, it happens to be the same as what we did previously, because your degrees of freedom is the same as the last example, as well as your level of significance. So anything more than 5.991, we reject H0. Anything before that or lower than that, we accept H0. All right, so that's our critical value, 5.991. All right, so that's your step 1 and step 2 done. Now we're going to do step 3, which is the bulk of the workings. All right, so for that, I'm going to clear this entire board. So I can write that out. Okay, so the first thing you want to do is you need to write out your table. Like I said, sometimes they'll give you the template of the table to start you off. But if not, you just gonna have to do it yourself. So I'm gonna label the categories in this order with credit card first, then accounts, credit card, then it's accounts, and the last one you pay by cash. All right. Now, first column, it's what we observe, what's given to us in the question, and how many clients did they or customers did they find in paying with each of these methods. So there's 620, 260, 260, and then the last payment type is 120. Okay, and if you add that up, it's about 1,000, I think. Yeah, 1,000. That's the total. All right. Now, the next column is, this is also given to you. It's the percent that they expect. So I'm going to put FE and I'm going to put a percent sign there. This is given to you in the question. They remember what I said in the initial time, they observed that 60% paid by credit card, 60%. Then there was 30% that paid by accounts, and the last would be 10%, the remaining. All right, so that adds up to 100%. Now you're going to use this to get your FE values, the actual numbers for FE. Now remember, if we have 1,000 customers coming in now, and if previously we had 60% of them paying by credit card, then if the distribution was the same, then the number that we would expect would be 60% times the 1,000. So it's basically the 60% times 1,000. And that's the number you would enter here. All right. For the next row, it would be 30% because that's what we had initially, 30% times 1,000. And then the last one, so we can work this out. I think 60% is 600. Yeah. And then the next one will be 300. And then you can work the last one out as 10% times 1,000, or you could just say, look, already you got 900, so the remaining clients, which would be 100, would be here. Or just do it this way. 1,000 equals 100. So you still get back to your 1,000, as you would expect, but this is what your values are for FE, okay? This row here. That's how you work with your FE values. Okay, then the last column, just like before, you need to work with F0 minus FE all squared divided by FE. Okay, and that's pretty much the same as what we did before. This is your FE column. There's your F0 column. So you're going to use these two values to work out this last column. Right? You're going to plug it into this formula here, and you'll get each value. So I'll do that for you. First value is 0.67. 0.67. Then it's 5.33. 0.67. Then it's 5.33. And then lastly, 4. And if you total this up, okay, you get a value of 10. Now remember what I said earlier. If you recall, the rejection region was 5.991. So this was our critical value. And you can see that the value that we got is 10. So it's way past 5.991. It's on the right of it. So that means we do reject H0. So we reject H0. All right. And if you recall, in the first step, our H0 was that the distribution or the payment pattern has not changed. So I'll just write it out here just as a recap. Here, the payment pattern has not changed. That's what our H0 was. But you can see that we're rejecting H0. So that means the payment pattern has changed. So how we would state this in our conclusion, we would say at a 5% level of significance, right, the data suggests that the payment pattern has changed. And that's how you would conclude this problem. All right, and that's pretty much it. That's the chi-square distribution. It's I guess it's what you can expect in the upcoming exam. So make sure you understand this You just basically 5 steps to answer those problems. State your H0 and H1, step 1. Step 2, find your rejection region. Step 3, it's this table here that you're going to create to find your test statistic. Step 4, do you accept or reject H0? And then the last step is write the conclusion out, like how I told you, okay, for this example. At a 5% level of significance, all right, the data suggests that the payment pattern has changed. That's your last step, step 5. Okay, let's move on to the next question. All right, so the next question, okay, it's also question 6, but it's because I took it from a different paper, all right? But the question is more important than actually the question number. So this question, I'll write it out briefly, not the entire thing. So they say they find 1 out of 10, this is what they find 1 out of 10 people who visit a website end up spend, so I'm going to put SP, spend more than 700 Rand. All right. Okay, so it's basically out of every 10 people that visit this website, they find that 1 of them tend to spend more than 700 Rand. Now what they're saying in the next part of the question is, if we randomly select a sample of 12 visitors, so a sample means a small n, they take 12 visitors, all right, they want to know the question here for this 6.1, the first question, 6.1, is what is the probability, what is the, I'm just going to write this for short, for probability, what is the probability that no more, and this is key, that no more than 3 of the visitors will make a purchase of 700 Rand or more. So the 700 Rand can kind of throw you off. But the thing is, you're not really using that 700 Rand, that number exactly. You can just think of it as a client spending what you want, all right? So what they're saying is they want to know what's the probability of no more than 3 of the visitors spending what you want. So if you were that store owner, for instance, all right? So we don't really care what they spend. We just want to know whether they spend more than 700 or not. So here, there's only 2 events that can happen that we're actually interested in. They either spend more than 700 or they don't spend more than 700. So that's 2 events, and they're the opposite of each other, or in other words, they're complementary events. All right. And we have a fixed number of trials. That is, we only have 12 customers. So when there's only 2 possible outcomes, which are complementary events, we have a fixed number of trials, as we have here, 12 customers, and they are independent. And when I say independent, you can just use your discretion here, because think about it. If a client comes into the store, the next client is not really dependent on that client. So if you say, Victor, if I go to the store and I spend more than 700 or not, that's not going to influence your decision on whether to spend more than 700 or not. Okay, if that was the case, they would state that in the problem. But here you can safely assume that it doesn't. So we are independent events. With those 3 things being satisfied, then you know that you need to use a binomial distribution. All right, okay. So now that we know we need to use a binomial distribution, all right, the 2 things that you need for binomial distribution, as I mentioned earlier, is your sample size, your n, and your p. All right, you need those 2 values to work out any probability. And in our case, the p is the probability of an event happening, which is that they spend more than 700, and that they give that to us. There it is. That's our p. Our p is 1 over 10. You can write it as 0.1 if you prefer. It's up to you. Decimal or fraction. Your n is given to you. It's 12. Now, what they're asking for the first question, it's kind of tricky here. They're saying no more than 3. Okay, so let's assume for a second it was more than 3. If it is more than 3, that means X can be 4, can be 5, can be 6, etc., all the way to 12. But they're asking us for no more than 3. That means it's the opposite of this. So what they're asking is that X can take on 0, it can take on 1, it can take on 2, and it can take on 3. So those are the values it can take on. So what they're asking us is to work out the probability of X less than equal to 3. And so you'd have to work out each of these probabilities for the different X's. So you'd have to work out probability of X being 0. I'm just going to write 0 instead of X equals to 0 just to save space, but know that it's the same thing. So that's going to be plus probability of X equals to 1 plus probability of X equals to 2, and lastly probability of X equals to 3. You need to work out each of these and then add them up. All right, and how you work out each of them is you use the binomial formula, which is in your formula sheet, which is, if you want to work out the probability of, let me make some space so I can write this out better. Just give me a second. Okay, almost done. I just need this little bit of space here. Okay, good. So for this first one, let's just say I want to work with probability of X equals to 0. You would use the formula here, P to the X into 1 minus P to the N minus X. All right, so for here, the first one, this one into 1 minus P to the N minus X. All right, so for here, the first one, this one here that I'm circling, your X is 0. So where you see X, you put a 0 there. So it's going to be P to the 0 into 1 minus P to the N minus 0. And we know what our N is, okay? There's our N, is 12, and our P is 0.1. So you plug these values into the equation here, and you get a value of, I'll tell you now, which is, I wrote it down to save some time, 0.3487. That'll be 0.3487. So that's what this value is. And you do that for each of them. Okay, so you're going to be changing the X value in this equation for each of them, but the N and the P remain the same. And once you work out all of them, all 4 of them, you add them up, and your final answer would be, I'll tell you now, 0.9872. Your final answer would be 0.9872. All right, so you got to work out each of them. I did the first one for you. This is probability of 0. You got to do the rest, probability of 1, probability of 2, and then lastly probability of 3, and then you add all of them up. And that'll give you an answer of that, 0.9872. Okay, does it make sense? Or are there any questions? So if I move on.
No, all is making sense. Thank you so much, sir.
Cool, glad to hear it.
Yeah.
Okay, I'm going to clear this board. All right, the next question is 6.2. Right, cool. So it has been found. All right, the question says it has been found from experience that there is an average of 4 faults. So there's an average. Second, it's an average of 4 faults per 50 meters of cloth, per 50 meters of cloth. Four faults per 50 meters of cloth produced in a factory. All right, and they say if we if we randomly select 50 meters of cloth, what is the probability right, that there will be no more than 2 false. So they're asking us what is the probability of that there will be more than 2 false? What is the probability of having more than 2 false? Okay. Now, thing is, you got to identify what probability distribution are we talking about here. Now, whenever there's an interval, and it could be time, it could be distance. Like in this case, you can see it's distance. It's every 50 meters of plot. So not necessarily time, but it's still a fixed interval. So you got this cloth, let's say it goes from here to here, and we can break it up into 50-meter intervals. It's 50 meters there, 50 meters here, and 50 meters here, etc. Okay, we can split it up into equal intervals, and there's an average given per interval. So per interval, you can see there's an average of the number of faults. So it's an average for, it could be 3 here, it could be 5 here, but on average, if you take a lot of these intervals, the overall average is 4, right? So it's 4, we'll say there's an average per interval. So basically all you need to take away from this is, if there's a fixed interval and there's an average given per interval, then it's a Poisson distribution, right? That's how you identify it. If you see an interval, could be time, could be distance, and there's an average given for that interval, then it's a Poisson distribution. Okay, so the first question is this question here. What is the probability of having more than 2 false? So what they're asking us basically is they're asking us what is the probability of x greater than 2, more than 2 false, where x is the number of faults, okay, in that interval. So if you want to work with probability of x greater than 2, now remember for Poisson distribution, your x can go up to infinity. So you have to use the complement rule. You can't work out x equals to 3, 4, all the way to infinity. You'll never finish the exam on time, all right? You have to find a shorter way to do it. And the way to do it is using the complement rule. So if you want probability of x greater than 2, you use the complement rule, which is 1 minus the opposite of that, which is x less than equal to 2. All right, so I'm just going to get rid of that. Remember, it's less than equal to because here you got greater than on the left. So the opposite must include the 2. So what you'd work out is 1 minus, and you need to work out each of them. X less than equal to 2 means x can be 0, x can be 1, and x can be 2. That's what you have to work out. So you got to work out this, and this using the Poisson formula. The Poisson formula is given to you. You don't have to worry about memorizing it. Remember the formula. Sheesh, I don't even have the formula with me. I just don't have the formula sheet, but I think it's all right. Let me just get it before I quote the wrong formula. Give me a second. Almost there. Sorry. Okay, got it. Yeah. Okay, it's e. It's exponent e to the minus a, which is your average, times a to the x. So times a to the x all over x factorial. So this formula is given to you, so you don't need to memorize it. Okay, this is how you use it. So remember your a is given to you. This is your a, which is 4. That's your a. And then your x is basically each of these values. This is your a, which is 4. That's your a. And then your x is basically each of these values that you're trying to work out here. Each of these values. So if I wanted to work out probability of x equals to 0, so I'm just going to write 0 instead of x equals to 0, but it's the same thing. If you wanted that probability, you would use this formula, but you would substitute 0 for x. So it's e to the minus, and your a is 4, times a, which is 4 to the 0, because that's what our x is here, divided by 0 factorial. And if you plug this into your calculator, you'll get a value of, I'll tell you now, 0.0183. So this value here, this first value is 0.0183. And you would do the same thing for each of them. Okay. For the next one, if you do probability of x equals to 1, the value you get is 0.0733. 0.0733.
Ask what is
Yes, Victor.
E quickly?
E is a value in your calculator. It has a value. It's something like 2 point something. You don't need to memorize the number, but it. Do you have your Casio calculator there?
Yes, I do. I do.
Okay, so if you take it out.
Yes.
Okay, so you just see one of the buttons. It has E above it. If not, just give me a second. I'll take out my calculator.
Okay.
So I can tell you where it is. Have you found it?
I have found it. Yeah.
All right. Right. So what you do is you can press Shift, then press that button where you see the E. Right, and then you'll see E with a block on top of it. Right, just put 1 in that block.
So
and then press equals to.
When I pressed Shift, it came up with pi.
No, okay, wait. So let me see in your calculator, you'd have this. Give me a second.
Right. Because I'm looking at the button that has times 10 to the power of x.
No. You'd see a button like this with your calculator. So look in your calculator for the LN button, LN. Can you see the button with the LN?
Yes.
Should
I
be
can, yes.
Right. Above that button, you'll see something like this, E with a block there.
Yes, I see it now.
Right. So what you do is press Shift and then press this button.
Right.
And then on your calculator, you'll see this flashing, right? So you need to enter a value for that square, and that's what you do here. See, like what you're doing here, e to the minus a. So you're going to put in -4. So if you type you just put -4 in that block.
Right.
Okay, then you're going to come back down now because your cursor is still blinking on the top. So now you're going to move down. So you move right on the cursor, that big blue circle button, until your cursor moves down to the normal height. So you'll have e to the -4. Now your cursor is in the bottom, so you're going to type multiplication times. All right, now you're in the next part, which is a to the x. So you're going to type, your a is 4, so you're going to press 4. All right, but now you want the exponent for 4 because this x here is the exponent for 4. You need to press this button here, which is, I'll tell you now in the calculator. You press this button here, x with a square above it.
Right, I see it.
Right, so now it takes you back up here to the exponents. So you're going to enter 0 because that's what our x value is. All right, then you're going to move your cursor back to the right so it comes back down. And you're going to press divided by, division. Divided by, and then you're going to enter 0 factorial here. Now you're in the denominator. So you're going to enter 0, and then the factorial button is where you see the exclamation. And the exclamation is on, I'll tell you now on your calculator. No, it's there. Give me a second.
Oh my God, it has a x to the power of -1. The button.
Yeah, that's it. Yeah. That's it. You'll see x factorial there.
Yes.
Yeah.
So you press
So
shift.
if you press shift, press shift in that and then hit equals to, and you get 0.0183, right?
Yes, I do. Thank you.
There you go. That's how you get it.
That
Yeah.
really
So
helps.
that's how you use the calculator to do it. Okay.
Yes.
No worries. Okay, so that's how you do it. You work out each of these, and then remember to take 1 minus what you get for the sum of those three values. So the final answer you get is 76.19%. Or you can leave it as decimal, 0.7619. There you go. If they tell you to interpret your answer, then provide a statement in the end, okay? So say whatever the problem is. So you would say the probability of having more than 2 faults per 50 meters of cloth is 76.19%. Yeah, if they tell you to interpret. So it's probably just good to put an interpretation there, just to be safe. All right. How are we doing for time? Just give me a second. I think we're out of it. Okay,
Okay.
but Victor, can you confirm that you know how to access the questions now?
No, sir, I'm still struggling, eh? I won't lie.
So wait, can you go to more resources while I'm here?
Yeah, I can go to more resources. So under the
Okay,
course, I'll go to more
yeah,
resources.
then go to. Can you see the revision folder?
I actually can't see. I see lecture slides, ICE activities, case studies and activities. Then there's PAS, module
Oh, wait a
outline.
minute. Wait. Hold on.
Yeah.
I think it's because it's hidden from students. Wait,
Okay.
hold on. Give me a second. Can you try it now? Just refresh
Yeah.
your page. Okay, no, don't refresh the page because I think you're online now. Just check if you can do that.
Okay. I'll go into it.
More resources, revision.
I'm trying to go there now. Ah, revision.
Yeah, you can see it now. Okay, you know what? That was my fault
Yes.
because it was hidden. I don't know why the system hid it, but that's
Oh,
annoying. Okay, but now can you see it? So
thank
revision
yes.
and then past paper questions.
Yes.
Okay, those are the questions.
Thank you.
No, you're welcome. You're welcome. But yeah, so work through those problems. They're quite good. But yeah, so work through those problems. They're quite good. If you're kind of stuck with any of them, then yeah, just email me. You can email me your workings as well if you want, and I'll have this quiz through it and tell you if you're on the right track.
Okay.
Okay, so and yeah, I guess this applies for all the students who are going to watch this recording as well. So yeah, that's it from my side. Yeah, please start revising, start working through problems. If you're stuck with anything, drop me an email. Yeah, try not to leave it, please, for the last day, the day, 2 days before the exam. I know students start to
Yeah.
scramble then, but try not to do
Yes.
that because, yeah, it's going to be very difficult for me to respond to everyone within that short space of time. So, yeah, start
Definitely.
prepping from now.
But this was really helpful. I won't lie. Thank you.
Good. I'm glad. That was the hope. Thanks. I'm very happy to hear that, Victor.
No
All
problem,
right.
Mr. Brown.
That's it from my side, everyone. And yeah, Victor, all the best. And
Thank you.
yeah, good luck for the exam.
Thanks. Have a good evening.
You too. Cheers.
Cheers.